All right, we're in Unit 2. This is Lesson 6, page 176. And these are the first couple questions that we'll work through and I will model for you before you start some of the practices. So your teacher will assign you one of these expressions, and actually I'm just going to choose the one for you. And then we're going to focus on one expression, and that's this one, okay? Because it's going to be a little bit easier for time's sake. Here it's n squared minus 9 divided by 2 times the quantity 4 minus 3. Now, I like this one because we can do some simplifying. N squared minus 9 divided by, well, 4 minus 3 is just 1, right? 2 times 1 is just 2. So n squared minus 9 divided by 2. And here it says evaluate your expression when n is 5. Okay, so if n is 5, that means we have 25 minus 9 divided by 2. So that's equal to 16 divided by 2, which is 8. Okay, so for number 1, that's 8. For number 2, let's say that it's 7. So 7 squared is 49. 49 minus 9 divided by 2. So 49 minus 9 is 40. Divided by 2 is 20. Okay. How about this one? Well, 13 squared is 169. 169 minus 9 divided by 2. 169 minus 9 is 160. Divided by 2 is 80. And the last one right here, well, negative 1 squared is 1. 1 minus 9 is negative 8. So negative 1 squared minus 9, I'll divide by 2. That's the same thing as 1 minus 9 divided by 2, which is the same thing as negative 8 divided by 2, which is the same thing as negative 4. So negative 4 is the answer. So we were able to evaluate those expressions. The next problem set asks us to write as many equations as possible that could represent the relationships between two children in the family that's described. We're not going to list every single one, but I do want to give you at least one example here. So I'll give you a model. Maybe on your own time, if you'd like to do your own, that's okay. For 1A, in family A, the youngest child is 7 years younger. Okay, so the youngest is 7 years younger than the oldest, who's 18. So if we think about it, the 18-year-old, right, is 7 years older than or more than the youngest child. Why? Okay, so we wrote an equation right here. I mean, if you really wanted to think about it, you could subtract 7 over and say 11 equals y. That could work. So we know the youngest child is 11 years old. That's a possibility. That's another one. You could also say 18 minus y. 18 minus the youngest is going to give us 7 years, or the difference between the ages of the 18-year-old and the youngest is 7 years. That makes sense. We're going to move on to letter B here. In family B, the middle child is 5 years older than the youngest child. So the middle child is 5 years older than the youngest child. Okay? So M, the middle child, is, whenever we see the word is, we should always think equal sign. Equal sign. Is means an equal sign. So whenever we see that, we should think this is like 80-90% chance that we're using an equal sign. So the middle child is 5 years older or more than the youngest child. Why? Cool. Tyler thinks that the relationship between the ages of the children in family B can be described as 2m minus 2y equals 10. Where m is the age of the middle child and y is the age of the youngest. Explain why he's right. Well, let's actually go back to the previous question here And if m equals 5 plus y, m equals 5 plus y. Okay, but here's the thing. We look at our equation and that equation. They don't look the same. They don't look the same. So let's make it kind of look the same. We notice that it's 2m minus a 2y. So we need to change this to this side. So let's equal sign highway minus y minus y. So m minus y equals 5 because this goes to 0 now. Okay? But it's not m minus y equals 5. It's 2m minus 2y equals 10. So that means we just multiplied everything by 2, right? So we multiply by 2. What we do to one side, we have to do to the other side equally. So 2m minus 2y still equals 10. So why? Because we can apply opposite operations. And then we'll also apply multiplicative equality. Multiplicative equality. What you can multiply to one side, you can multiply equally to the other side. Okay. Very good. Question 3. Are there any of these equations equivalent to one another? So are any equal to each other? Let's find out. If we can say that a equals something that's the same, then they're going to be equal. So let's solve. Okay, equal sign highway minus 6 equals. Divide or subtract, that becomes 0. 3a equals 9. Oh, we already see that there. We should be, yes, this is good. But then let's divide each by 3. Divide by 3. A equals 3. Okay. This one's much simpler because we're just at this point. So we equal sign highway, divide by 3 equally. 3 divided by 3, those cancel out just like they did in the previous example. And we can say a equals 3. Okay. So that's equal. Okay. How about this one? Well, we can subtract 2 equally to both sides. I got trigger happy there. Equals minus 2. So minus 2 and minus 2. Those cancel out, and you're left with a equals 3. Cool. And then the last one. Well, 1/3 times a equals 1. Well, this is actually the same thing as like 1 divided by 3. So the opposite of dividing by 3 is multiplying by 3. So let's multiply each side by 3. Multiply by 3. And 1/3 times 3, that cancels out to 1, and we're left with a equals 1 times 3, which is 3. So all of them are equal, and we're using like opposite operations here. All of these are opposite operations. So subtract, divide, subtract, multiply, opposite operations. Okay, very good. So yes, they're all true. They are all equal in solutions. They all have equal solutions. Next, Noah is buying a pair of jeans and using a coupon for 10% off. The total price is $56.70, which includes a $2.70 sales tax. Noah's purchase can be modeled by this equation. Well, X is the original cost of the jeans minus 10% or 0.1 times X plus $2.70 equals $56.70. How does the equation represent Noah's purchase? Well, that's going to be a good question for us. Well, here is the original gene price. Here is the coupon. Here is the tax. And here is the total price. So labeling all of these are going to be really important for us. So that's how the equation represents it. We have each of the parts, right? The gene, how much the genes cost, the coupon, the tax, and the total price. So while you don't need to discuss with a partner, you can. What does the solution to the equation mean in this situation? Well, that's the original gene price. Original gene price. How can you verify that 70 is not a solution, but 60 is the solution? Well, we can simply substitute. So we can substitute 70 and 60 in for our x's. So there's two x's. One is right here, and the other is right here. So 70 and 70 would not give us 5670, but 60 would give us 5670. Here's some equations that are related to this. Each equation results in performing one or more moves to the original equation. Each can be interpreted in terms of Noah's purchase. For each equation, determine either what move was made or how the equation could be interpreted. Then check if 60 is the solution. Okay, so here we see that it's 100 minus 10 plus 270, 5670. So multiply all by 100. Multiply. Okay, so we multiplied all by the 100. The interpretation is here, and the same solution, yes. What was done? Well, we see a subtracting of $2.70. Subtract 270. So that's the take away the tax. And yes, that would be true. 9.9x plus 270 equals 5670. Yes, as well.